Hey, it's Mr. Kabbalah. In these geometry recap videos, I'm trying to focus just on the most important topics in each lesson. I hope they're a help. Let me know if you have any questions.
So I think one of the most important pieces in Unit 8, Lesson 2, the trigonometric ratios, is knowing which side is which. So the hypotenuse is always opposite the 90-degree angle. In fact, I've often shown people that if you take the right angle symbol and make it into an arrow, that arrow actually points to the hypotenuse. So that's one way that you can always identify the hypotenuse is by going across from the 90-degree angle. Now, with trig, I call the angle that we're dealing with, like this one says x, so it could be anything. I very often call that the reference angle. I might be the only one that does, but that helps me out. Basically, that's the angle I'm referring to. So all of the other sides are in reference to that angle. So when we use SohCahToa, 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 the S stands for the sine, C stands for the cosine, T stands for tangent, and then the O stands for opposite, H for hypotenuse, and A for adjacent. So in terms of this diagram, the opposite would be green, and that's because it's opposite that reference angle x degrees. The adjacent side, it's not the hypotenuse, it's the other side that helps make that reference angle. So that this blue side would be the adjacent side to x. And then the hypotenuse is always the hypotenuse. So I'm going to go through some suggestions as we continue forward, dealing with the sides of a right triangle and these ratios. One thing that really confuses people is that if the reference angle changes, like in this one, kind of like what we just did, if the reference angle is here, then the opposite side would be that green side. The hypotenuse, again, is opposite the 90-degree angle, and so it leaves this blue side as the adjacent. But if we were to change the reference angle so that it's now here, then what happens is that, the hypotenuse is still the hypotenuse, but the opposite side now becomes this blue side, and then this green side becomes adjacent. So you got to be very careful with your reference angle and what's opposite and what's adjacent. So moving forward, again, here's a little illustration. If this is our reference angle, x degrees, again, we'd have opposite side, which is over here. We have our hypotenuse, which is opposite the 90-degree angle, and the adjacent. But what happens is if we, let me get rid of, if we change this x so that it's now up in this corner, what happens is that the opposite comes down here and the adjacent comes here. And notice that the hypotenuse doesn't change, it's still the hypotenuse. And that's because it's across from the 90-degree angle. So, which side is the hypotenuse? It's opposite the 90-degree angle. So here's the 90-degree angle. It's pointing right at the hypotenuse. This is asking which side is opposite angle Q. So again, same drawing. So this is the hypotenuse. This is our reference angle. So across from it would be the opposite side to angle Q, which would be PR. Which side is adjacent to angle Q? So again, opposite the 90-degree angle is the hypotenuse. Here's our reference angle. Okay, so it's not the hypotenuse, it's the other side that makes that angle, so it would be QR. Which side is opposite angle P? So again, there's the hypotenuse. That's not going to change. Right? Opposite angle P would be QR. And then adjacent to would be, there's our reference angle, there's our hypotenuse, so it would be PR. And I did that just to kind of show that the adjacent and opposite sides of a right triangle depend upon which angle you're focusing on. Again, I call that the reference angle. So what are the sine, cosine, and tangent of angle E? So first we're going to do this by sides. So what I like to do first is find the hypotenuse. So there's the 90-degree angle. It points to the hypotenuse. So the hypotenuse is down here, side DE. Right, now we're talking about angle E. So our reference angle is this one here, right? So the sine, so we're going to do SohCahToa, S-O-H, so opposite and hypotenuse. So opposite angle E is DF. So it would be DF compared to or divided by the hypotenuse, DE. Cosine is Ka, so SohCahToa. So it's adjacent to the hypotenuse. So the adjacent side to angle E would be EF. And the hypotenuse again is DE. Tangent E would be the TOA, opposite over adjacent. So again, the opposite side is that DF. The adjacent side is that EF. Now there weren't numbers here, so if we put numbers in, we could make these into fractions. So I'm going to kind of go through these quickly, but again, it's angle E is our reference angle. The hypotenuse is always opposite the 90-degree angle. And with numbers, it's also the largest side of the right triangle, so 17 is the largest of these three. You could check that this is a right triangle by doing 8 squared plus 15 squared equals 17 squared. In any case, what we're going to do is the sine of E would be, again, SohCahToa. It would be opposite over hypotenuse, so it would be 8 over 17, which we then could get a decimal. For now, let's just leave it a fraction. For the cosine of E, that's AH, so adjacent. So these two sides make angle E. This is already the hypotenuse, so adjacent would be this side, which would be 15 over 17. And then finally, for tangent of E, it would be the opposite side, so there it is 8 over the adjacent side, which we already defined as 15. So 8 over 15. Now, some suggestions I would have is, when you're first doing these, label your diagram. And if there isn't a diagram, draw your own. So draw and label your own diagram. And then identify, so ID the hypotenuse first. That's easy to do because it's opposite or across from, come on now, the right angle or the 90-degree angle. And then from there, if you can identify the hypotenuse, then locate your reference angle. And then label the opposite and adjacent sides to that reference angle. So that's kind of what I would suggest as you move forward with these trig ratios. Hopefully we'll see you soon. Bye now.